Perhaps you've played with bar magnets, or have a magnet on your fridge. But did you know that the Earth is a giant magnet? In fact, this is how compasses work. In this video, we're going to look at Earth's magnetic field and compasses in more detail. But first, you need to know a little more about magnets, such as magnets have a north and south pole, and a magnetic field shaped like this. You may want to watch this video for a quick recap. Compasses show directions, but how do they actually work? Compasses have a freely spinning needle, which is a magnet. As the Earth is a giant magnet, the compass and the Earth act as any two magnets do. The north pole of the compass is attracted to the south magnetic pole of the Earth. Now this is a rather confusing part. The north pole, geographically as we think about it, is actually a south magnetic pole. But all you really need to know is that the Earth is a giant magnet, which is why we can use compasses to show us which way north is. Did you know that the North Pole is not the same as the magnetic north, as the North Pole is determined by the Earth's spin and the magnetic north by the direction a compass points? However, unlike any ordinary magnet, the magnetic Earth's poles can switch. So the North Pole becomes the south and the South Pole becomes the north. This pole reversal has actually happened many times before, and is likely to happen again soon. In fact, in the last 20 million years, it has switched every 200,000 to 300,000 years, which is quite often considering how old the world actually is. The proof for this magical reversal is right at the bottom of the ocean, on either side of the mid-Atlantic rift. As rising lava here solidifies, it becomes permanently magnetized in the direction of the Earth's magnetic field. And, by taking sediment cores from the surrounding ocean floor, scientists are able to see bands from the switching poles. You might now be wondering, how on earth, quite literally, can such a phenomenon occur? Geophysicists aren't entirely sure. However, they think it's something to do with the Earth's soft iron core being surrounded by hot, liquid metal, and the electric currents produced within this layer. So does the Earth being a giant magnet do anything useful? Well, it plays a big part in maintaining Earth's atmosphere. Solar wind is a flow of charged particles coming from the sun. The Earth's magnetism usually protects the surface of the Earth from these particles, but if some manage to get through, then we can see the aurora, also known as the northern lights. If there is no magnetic field, the solar wind would strip away the Earth's atmosphere, leaving the Earth's surface exposed to the damaging UV light rays from the sun. Interestingly, this gives rise to one theory about why Mars barely has an atmosphere. If its magnetic field was switched off somehow, then its atmosphere would have been broken down by the solar wind. So, there we have the huge magnet that is the Earth. The geographic North Pole is slightly away from the magnetic North Pole, which is technically the South Pole of a magnet. And then to add more confusion, the pole reversal happens every so often so that the magnetic North becomes the South for a few 100,000 years.